Hey gang, this is Gwen. It is Thursday, September 9th. I am doing the elephant toothpaste experiment that we are needed to do. The elephant toothpaste experiment. I'd like to go over why this reaction is going on. It is because this is a rapid decomposition type of reaction of hydrogen peroxide. And there is an enzyme called catalase in the yeast which speeds up our reaction. I've written the chemical formula as hydrogen peroxide, and then it breaks down with the yeast from the catalase into water and the oxygen. I found that someone had calculated the amount of enthalpy change in the reaction. It was roughly negative 196 kilojoules per mole. And the oxygen is giving off, causing a little bit of that explosion part that we're going to be expecting to see. And that the negative from the enthalpy change is actually heat that is giving off to the surroundings and making this an exothermic type of reaction. So basically, we're going to take hydrogen peroxide, mix it with some yeast and the enzyme catalase to speed up the reaction. Otherwise, from what I understand, it would not react. It would take a long time for it to react. And we would see some heat, which is given off into the surrounding. And here is my setup. I have the food coloring. I have all the things, and that's like some warm water. And I'm going to use a milk jug. Okay, we'll see how this works. I am also going to prepare the ingredients, so you can just kind of watch while I do that. The first step is to just mix warm water with the yeast. And I'm actually going to do a quarter cup of the water. I don't know if you can see it, but quarter cup of the water with the yeast. And I have this yeast for help active dry. Yeah. And I'm going to put this packet in here. Then I'm going to mix it up. So mix it up pretty good. That's the first step in this process. So we have our yeast. The next step is to take half. I only could find 3% of the hydrogen peroxide. I guess you have to order it. I went to 3 different stores to find the higher concentrations. What it simply means is that if you have a higher concentration of the peroxide, you will have more of an explosive reaction. So I'm going to just stick with the 3%, and I'm putting in half a cup of the peroxide into my jar. The next thing I'm going to do is add a few drops of food coloring. So I'm going to add blue to the sides. And then I'm going to add green. So it'll be like a blue-green. A couple drops of the green. And then I'm going to add a few drops of the Dawn dish soap to our jar. A few drops. And I guess the soap actually traps some of the gas of the oxygen, is my understanding. Yeah, so that's why we put the dish detergent in there. And now, the grand finale. we're going to add the yeast, and we'll see if we get our reaction, the expected reaction. I don't know how much to add. Oh, it's a slow reaction because of the 3%, but you could see the foam is rising. It's going up. I'm probably going to swirl it just a little. And you could see it's making that, the food coloring is at the bottom. And again, I think it's because, you know, essentially I had a 3% hydrogen peroxide. And if I had a 6%, 10%, 20%, or potassium iodide, I couldn't find those reactants, but I stuck with the simple 3%, and it still worked. And it's starting to foam over the top. Not the best explosion, but I'm okay with that. As you can see, it's coming out. It is warm to touch. It's not like super hot, but I would say this is a very small success on a small level of this elephant toothpaste experiment. Again, it is a decomposition of hydrogen peroxide, and yeah, that's what I got. Okay, thank you. Hope you enjoyed that little tiny experiment. It was kind of interesting. I would have liked to find more products, but reactants, but I get what I get right now. All right, thank you. Bye.